Okay, so we are doing simplifying rationals. Rationals really all just means that we're dealing with fractions that have letters on the top and the bottom. Yes? Okay, so the first couple in our notes are pretty normal. It's not something we haven't done before. It was when we were dealing, sorry, I'm throwing things. It's when we were dealing with exponents, okay? So it's going to look pretty normal, and we're going to like those. The new part is the domain part. So we're going to talk about that for a second. What I want you to realize is that your domain, what is domain?
X.
What about x? It's like all possible x values, right? It's all possible x values. Now, here it's going to be all possible whatever letter is there values. Okay, so usually it's x, but every once in a while, like here it's b and r. Okay, here it's a and c. So it's whatever letter is there. Okay, because we're not solving, so there's no y. So your domain is just whatever you're solving for. Now, there is a proper way to write domain. I'm going to show you that. But it's very wordy, and I'm not going to make y'all do all that. Okay? But I want you to understand it. So this is one of our practices. You'll see I typed it out for you. It's multiple choice. So it's either pretty much, is it real numbers, like all real numbers, or is it all real numbers except for something, which you'll understand after today. Okay, so we're just going to focus on what it can't be, and if you can understand that, then you'll be good. So this just means, I'm going to show you all, I'm going to read it to you properly. It says x such that x is all real numbers or a real number, and x cannot be whatever, okay? Or x such that x is all real numbers. So it's just saying x is my variable and x is all real numbers, or x is my variable and x is all real numbers, but x is not this. Okay, so that's all it is. But we're going to kind of cheat, and we're going to write it way simpler. Yes? Make life easy. Because do we really want to write all those words? Now in college, you will write words. You also have a lot of symbols, but I'm not going to teach you all that yet. You'll learn all that in college algebra. Yes? Okay. So things to know. It is okay to have a 0 on top of a fraction. Whoa. Okay, it's okay to have a 0 on top of a fraction. It is not okay, no, on the bottom. Yes? So if you watch, if I do alpha y equals enter 0 over 4, it tells me 0. That's okay. That's a number, right? So it worked. But if I do the opposite and I do 4 over 0, it tells me error, you divided by 0. It's not, you can't do that. Okay, so that's not allowed. So you can't have a 0 on the bottom. So that's where domain comes into play. That's what restricts our variables today. So we cannot have 0 in the denominator. Well, when you're multiplying, what makes 0? Multiplying by 0, right? Now, when adding or subtracting, it's whatever cancels to make 0, right? But when you're multiplying by 0 gives you 0. So B, we like when it's multiplying. So domain. So when multiplying, variables cannot equal 0. I'm going to write it out instead of putting a circle. Okay, because anything times 0 equals 0. So if I plugged in R or B is 0, wouldn't the whole thing end up being 0? Because you multiplied by 0? Yes. So that's why that's not allowed. Well, the nice thing is, if you look at number 1, number 2, and number 3, aren't those all multiplication in the denominator? So all of your letters just cannot be 0. So those are easy domains. So let's look at number 1. You find your domain before you simplify. Okay, so when multiplying, and then find before you simplify. So I like skipped a letter. Find before you simplify. Okay, so B cannot equal 0 because we're multiplying. And R is squared, but 0 squared equals what? 0. So R can also not be 0. So therefore, B can be any number, any real number except 0. R can be any real number except 0. And now, how would I simplify this? Well, there's a couple things I want you to know. I had a student the other day text me, I didn't know, but on Remind, apparently y'all can still reach out to me after you graduate. I still get it. Okay, so I had a student text me, and she told me that she wanted me to show her how to do a problem because it's the way I used to solve it, and she's like, you were better than my teacher. Not to toot my own horn, but she's like, I just like the way you did it. It was simpler, because in college, they don't always make things simpler. They'll tell you the proper way, and that's not always the simple way. So she just wanted me to remind her how we did it. So I showed her, and I asked her, because I showed her how to do it in these calculators, and she's like, well, we can't use those. They consider that cheating. And I will tell you, it's some campuses, I don't know if it's a campus decision, I don't know if it's a professor decision. I'm pretty sure it's a professor decision. But some professors don't let you use TI-84 in college algebra. Some of them do. It's up in the air. So I'm going to show y'all on the first two simple ways to help you simplify fractions without using the calculator. But in my class, are you allowed to use the calculator? Yes. So after we get through with the first two, can we go back to just using the calculator? Yes. So I'm going to show you because I want you to understand, but at the same time, we can use the calculator as well. Cool? Okay. When you have smaller numbers, 14 and 4 are not huge numbers. You can do, well, are they both even? Are 14 and 4 both even numbers? Yes, so you can cut them in half. When you have even numbers on top and bottom, you can cut them in half. What's half of 14? 7. And what's half of 4? 2. Well, 7's prime, so does this break down any further? No, so look, we're done. We simplified. Okay, now we look at our letters. Remember with letters, when you're dividing, you find where there's more. So where are there more B's? There's 5 on top, 1 on bottom. So there's more B's on top, so B stays on top. And what do we do with the exponents? Subtract. So what's 5 minus 1? 4. And where are there more R's? Bottom. There's 2 on the bottom and 1 on top, so R stays on bottom. And 2 minus 1 is what? 1. Do I have to put an exponent of 1? No. So there's your answer. So like I said, that's really not new for y'all other than the domain part. Okay? So this one, number 2, any questions on number 1? Okay, number 2 is a little different when it comes to simplifying because they're not both even. But before we do that, because before you simplify, you have to find your domain. We have 2 letters. We have x and y, but is the whole denominator just multiplying? Yes. So what can x and y not be? So when it's multiplying, they just can't equal 0. So x cannot be 0 and y cannot be 0. We like when it's multiplying because it makes our life easy. Okay, so now, when it comes to simplifying, when the numbers are not both even, you can't just like cut them in half. You can think of GCF. What's your GCF of 18 and 15? It's not 3. Okay, 3 goes into 18 how many times? 6 times. 3 goes into 15 how many times? 5. So you can break it down with your GCF. Now, if you're not sure of the GCF, but you know a number that goes into both of them, you can also use that method, and then you could break it down further. So like if 6 and 5, like if 3 wasn't the GCF, but it was a number that just went into it, we could try to break down 6 and 5 further, but those don't break down, well, 5 doesn't break down further, so we're good. So 3 and 3 cancel when you're dividing, right? And what's left? 6 over 5. And that's as simple as that gets. 6 over 5, 5 is prime, 5 does not go into 6, so we're done. So that's another way to simplify without using a calculator. Yes? Okay. Now letters, where are there more x's? Top. And what is 5 minus 2? 3. And where are there more y's? Trick question. Are they the same? What happens when they're the same? They cancel. So that equals 1, or 2 minus 2 is 0. Anything with a 0 power equals 1. Well, anything times 1 is itself, so does anything change? No. Okay, so let's look at number 3. Okay, so this one's a little different. It's still multiplying, but it's just separated. Okay, so let's find our domain really fast. We still have two letters. We have A and C. Everything's multiplying. So again, A cannot be 0. C cannot be 0. That's it. Now I'm going to cover that up really fast. I'll put it back in just a second. But we're going to talk about simplifying our letters now in the calculator. Numbers, sorry. On the top, you're multiplying. On the bottom, you're multiplying. With multiplication, it's not like addition and subtraction. Nothing has to match. You just multiply across the top, multiply across the bottom. So 7 times 63 over 9 times 35, and I get 7 over 5. Yeah? You could do it in your calculator. And I'm just going to bring my letters over, and I'm going to put them in alphabetical order. So A squared C. That way they line up, and it just makes my life a little easier. Okay, so where are there more A's? At the bottom. And what's 2 minus 1? 1, thank you. Okay, so do I have to put the 1? No. Where are there more C's? Top. Now what's 3 minus 1? 2. Is that as simple as it gets? Yes. Okay, everybody good on that one? Okay, look at number 4. Number 4 is different. Why? What's different about it? Well, we have, what? We have subtraction, I think is what I heard. Yes? So now it gets different. Okay, domain is not as obvious because we can't just say 0, because 0 squared minus 4 does not equal 0, so that doesn't help me. Okay, we actually have to factor. So when you have addition and subtraction, you want to factor your top and bottom fully to figure out if you can simplify and to find your domain. So let's start, I always start with one, either the top or the bottom. Okay, don't try to do both at the same time. You're going to throw yourself off and mix things up. Okay, so let's look at just the top. What's wrong with it? What should we check every time we factor? In order, and what else? After we check order, what should we check? Starts with a G. The GCF. So we're going to put it in order. I want you to realize this is plus 6. So when I put it in order, I have negative 3k plus 6. Now I have to check for a GCF. Does it have a GCF? What is the GCF? 3. But what kind of 3? Why is it going to be negative? Yes, but what's negative? Not just the 3. It could be anything. It's because the first term is negative. Do y'all remember that? When your first term is negative, you have to take out a negative. Okay, so even if your 3 was here and your 6 was there, it would still be negative 3. Okay, so negative 3 is my GCF. And when I divide by that, I'm left with k minus 2, because 6 divided by negative 3 is negative 2. This is not my best color. Okay, I think I just made it worse, but it's fine, I think. Okay, so now we have to do the bottom. Well, how can we factor that denominator? Can we factor that denominator? Yes, how? What exponent do you see? A squared. So k squared is a perfect square. Is 4 a perfect square? And is it subtraction? So is this a perfect square minus a perfect square? So can we figure out what squared minus what squared? Well, k squared. And what squared gives you 4? 2. Now, you won't have to memorize these formulas. I will have them for you all the time. But it's a plus b, a minus b, or a minus b, a plus b, doesn't matter. So it's k plus 2, k minus 2. Now, before I simplify, what do I need to find? The domain. These are different because I don't just have k times a times b or whatever. Like, I'm not just multiplying. I have addition and subtraction. What would cancel a positive 2 to make this factor equal 0? A negative 2. And what would cancel this negative 2 to make this factor equal 0? What's the opposite of negative 2? Positive 2. Now, I'm going to show you how to find those mathematically, but that is your domain. So you can literally take your two factors, almost like you're solving, remember when we were solving, and you can set them equal to 0 and solve. Well, how do I get rid of a plus 2? I would subtract 2. How do I get rid of a negative 2? I would add 2. So k equals negative 2, k equals positive 2. So that's what k cannot equal. Does that make sense? Okay. So that's how you'd find your domain when you have factors like this. Now, what matches? The k minus 2's. Now, when you have parentheses or when you have addition and subtraction, that addition and subtraction makes those terms stay together when you're canceling. So you have to cancel her whole, I don't know how I was about to say that word, whole terms. So k minus 2 has to cancel a k minus 2. Like, you can't cancel these k's and these 2's and be like, oh, cool, negative 1. Like that, you can't do that, okay? That minus and plus makes these stick together. So if the whole thing doesn't match, you can't cancel it. Well, k minus 2 and k minus 2, those match, so we can cancel them. And we're left with negative 3 over k plus 2. Now, I told y'all yesterday, I believe I did, that a lot of the factoring we give y'all in this unit, we try to be nice and give you some of the simpler factoring, just because we're not fully testing you on factoring, like we want you to still be able to factor, but we are going to ask you to factor. Okay, so just be ready. You will be factoring, but not super difficult problems. Okay, it's going to be pretty minor. Okay, so let's look at number 5. Okay, well, can your denominator or numerator factor at all? No. Why can this one not factor? Because it's a perfect square and a perfect square, but what's wrong with it? So you're right when you told me no. It's addition. Remember, with perfect squares, what does it have to be? Subtraction. So that's why that one doesn't cancel. Also, doesn't it already cancel? So, like, would it be a waste of time, kind of? Yeah. So there's also that. So here we have things that let's find our domain before we keep going. We have A and C. So we'll start with A. What can A not equal? Well, starting here, is it just multiplying? See how up here it's just multiplying? If we just look there, what would that be? Well, when it's multiplying, what can it not equal? 0. So A can't be 0. Looking here in this piece, what would make that negative 2 equal 0? Positive 2, right? If I plugged in 2, 2 minus 2 is 0. So that would cancel. Again, you could also set it equal and solve plus 2, A equals 2. Okay, now the A squared plus 4 is where it gets weird. So I'm going to talk it out and then I'm going to prove it to you. What cancels a positive 4? A negative 4. Will something squared ever equal a negative? Why not? Because when you square a negative, what does it become? And when you square a positive, what does it become? Positive. So will this ever cancel anything? Like, will that ever equal 0? No. So I'm going to prove it to you mathematically now. So if I have A squared plus 4 equals 0, I would subtract 4 from both sides. I get A squared equals negative 4, and then I square root. And what does it end up equaling? An imaginary number, right? Am I ever going to plug an imaginary number in? No. We don't even like solving for them. We're definitely not going to plug them in, okay? So that doesn't give me anything, and we're done. Now, we also had a C, but C was only multiplying, so C cannot equal 0, and we're done. Now, what can we cancel? What's super obvious that cancels? The A squared plus 4's. Okay, well, these sets of parentheses, will those ever simplify? No. So we know that those are going to be part of our answer. I'll leave some space in front. Now, 2 over 8, what does that simplify to? 1/4. So I'm going to have a 1 and a 4. And where are there more A's? Top. And 2 minus 1 is 1, so there we are. And where's the only C's? Aren't they only in the denominator? Because we're not looking at the parentheses. Those can't cancel because they're stuck with the minus 3. So they're only on the bottom, and there's none on the top to cancel, so it stays C squared. Now, would it be okay if you did not have that 1 in the numerator? If you just had A parentheses C minus 3? Yes. But if you put the 1, that's also okay. We're almost done, y'all. Bear with me. We're getting there. Okay, look at example 6. Can the top factor down at all? It's 2x squared. That doesn't break apart. So we're good. I mean, you can break apart the x's, but it's not worth it. So what about the bottom? Can you factor that? Well, first off, it's in order. Does it have a GCF? Yes. What's the GCF? 2 what? X what? Yeah, so 2x squared is my GCF. So when I take that out, well, 10 divided by 2 is 5. 3 minus 2 is 1, so we just have x to the first power. And what's anything divided by itself? 1. And my numerator is 2x squared. Now, before we cancel anything, what do we need to find? The domain. So x cannot equal, well, up here it's just multiplying, so what does that give me? 0. Now this one's a little harder because I have a number in front of my letter as well. So when I solve, what do I need to do? Add 1 and then divide by 5. Now if you don't rewrite it every time, that's fine. And what do I get? 1 over 5. Okay, now what cancels? Okay, and now what's your answer? Huh? Almost. 1 over 5x minus 1. Why does the 5x minus 1 have to stay on the bottom? Well, because it's already on the bottom. That's like saying you solved and you got a half and you're like, cool, I have 2. Are those the same? No, so make sure if your answer's on the bottom, it stays on the bottom. And can the top be empty? No, but you could put a 1 and that doesn't change anything. Now, what if the 5x minus 1 was on top? Would that be okay? Do you have to have a denominator? No. Now, if you put a 1 in the bottom, is that wrong? No. You almost made it. Okay, 7 is not the prettiest. We're going to start with the top. Okay, what's wrong with inside the parentheses? Huh? Yeah, we don't want to multiply back in because we've been factoring, right? So the 7's going to stay, but what's wrong with it? You were saying it. It's out of order. So how would I fix it? What would it look like if it was in order? Not x minus 7. Negative x plus 7. Now, I want to show you something before we keep going. If you factor the bottom first, now a is 1, so do we have to do the box? No. So a times c is negative 21, b is negative 4. What multiplies to give you negative 21 and adds to give you 4? Anybody? What multiplies to give you negative 21 and adds to give you negative 4? 7 and 4. Which one's going to be negative, though? I mean, 7 and 3. Dang it, sorry. I'm looking at the 4 on the bottom. The 7's going to be negative because negative 7 plus 3 is negative 4. Okay? So this is positive 3. Now, when a is 1, remember, you're just going to put x, and then you can do minus 7 plus 3. Now, this is what I want to show you. Is 7 minus x and x minus 7 the same thing? Do they match? The answer is no. They're super, super close, but when I fixed the order, now do they match? Do you see how they don't match? The x minus 7 and the negative x plus 7, those are not even close to the same thing. Okay, so be super careful. This is a mistake a lot of people make, and they would cross those out and be like, cool, 7 over x plus 3. And why that's close, it's not quite right. So what do I have to do to this top parentheses? What's not allowed in the front? A negative, right? So you have to take that negative out, and when you do that, you have to divide everything by negative 1. So you get negative 7 and x minus 7, because that became positive, and negative divided by positive divided by negative is a negative. Now x minus 7, x plus 3, and now these cancel. But before I cross it out all the way, which I kind of already did, what can x not equal? What would cancel a positive 3? Negative 3. And what would cancel a negative 7? So there's your domain. And what's my final answer? Negative 7 over x plus 3. Okay, last one. It says find the mistake, and we're going to talk through it together, and then we're done. Okay. I will tell you they are factored correctly, so we don't have to worry about that. They are factored correctly. So looking here, they canceled the m plus 4s right first. Is that okay? Can they do that? Yeah, so the first step's right. You can cancel the m plus 4s, we're good. So we had 2m minus 1 over 5m left, which is right. But what did they try to cross out? Just the m's. Do you see how they tried to cross out just the m's? Can you do that? When you have subtraction and addition? Remember how I said the subtraction and addition makes it like glue and they're stuck together? You cannot do that. So your final answer should have been 2m minus 1 over 5m. You cannot cancel the m's like that whenever you have addition and subtraction. Therefore, this cannot happen, and that's your answer.